Hey everyone, good morning. I am Pranshik and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is maximum absolute sum of any subarray. So it is very clear from the question name itself that what we need to do. We need to find the absolute sum of any subarray and we need to maximize it, right? Okay, let's read the question once. You are given an integer array nums. The absolute sum of a subarray is this, the sum of all the elements of a subarray, and you need to return the maximum absolute sum of any array, any subarray of nums. Okay, and absolute sum, what does this absolute sum means? Like if the sum of the subarray is negative, then you can take it as positive. Okay, so one very basic brute force approach for this can be like you can find out all the subarrays of a array and then find their sum and then maximize it. And the complexity for taking out all the subarrays of a array is n cube. You can simply run two loops I and j, and you will get one subarray from I to j. And you can optimize this to n square in the way that you can calculate the sum, you can keep track of your sum while in this I and j loop only. Let me show you how. Like you can start iterating on an array and then again start iterating on, let's say 1 2 3 4 5. You will start iterating from here. You will take 1 2 1 2 3 1 2 3 4 1 2 3 4 5 and then this. So in this way you can keep track of sum of all the subarrays and then maximize it, but its complexity is still n square. And as you can see from the constraints that nums dot length can be up to 10 ki power 5, so it will become up to 10 ki power 10, and which will give you TLE. So this is not going to work. So we need to think for the for the solution of complexity under n log n or something n. Okay, so whenever we think of a subarray sum, then what comes to our mind is prefix sum. As in the yesterday's question also, we were using the prefix sum. Okay, so let's see what is our nums. 1 minus 3 2 3 and minus 4. Okay, so let's store its prefix sum first and then we'll see what we can do. So initially prefix sum is initialized with 0, then 0 plus 1 1, 1 plus minus 3 minus 2, minus 2 minus 2 0, 0 3 3, 3 minus 4 minus 1. Okay, so let's say if I will ask you the sum of this subarray, so let's say this will be the left pointer and this will be the right pointer. So what will be its sum become? Its sum will become prefix sum of right minus prefix sum of left minus 1, right? Okay, so what we can do, prefix sum of right is 3 minus prefix sum of left minus 1 is minus 2, so its prefix sum is 5. Yeah, you can see as well, 2 plus 3 is 5. Okay, so for finding the sum of a subarray, we need two things, prefix sum of r and prefix sum of l minus 1. It means, let's say this one minus this one, and we need to get a sum with and maximize it. So let's say a and b. So what we can do is, so if we want to maximize the value given by a minus b, then a should be maximum and b should be minimum, right? So let's say as we have negative numbers as well in the nums, so a can be less than 0 and a can be greater than 0, right? As you can see, prefix sum can be less than 0 and greater than 0 as well. So let's say if prefix sum is greater than 0, so if it is a positive number, so we want to subtract the minimum number from it so that we can maximize its value, right? Okay, one case is this, that if this is a positive number, then we want to subtract the minimum number from it. Okay, but let's say if a is a negative number, let's say this, so what we want to do to maximize this value, we want to maximize this number. Why? Because let's say we have minus 2, so we want to subtract the largest number, let's say 7 10 or something, because let's say if we subtract minus 1 from this, it will become minus 2 plus 1, it will become minus 1, and then we will take its absolute value. But let's say if we subtract a maximum number, let's say 7 or 10 something, then it will become -9, or then we will take its absolute value and it will become 9. So as we in the question we have been given that we can take the absolute value of our sum. That's why if our prefix sum is negative, then we want to subtract a maximum number from it, and if our prefix sum is positive, then we want to subtract a minimum number from it. So here are two cases for for a particular prefix sum. Either we want to subtract the minimum number from it, or we want to subtract the maximum number from it, and then want to maximize its sum. Okay, so let's try run this thing once, then you will get a better idea. So what was our nums? Our nums was 1 minus 3 2 3 minus 4, 1 minus 3 2 3 minus 4. Okay, and here we will not create a prefix sum vector, we will create a prefix sum variable, as we have also created in the yesterday's question. If you have not watched it, then you can go and watch it once. Okay, and we will create a track of max value and min value, right? Okay, and our maximum sum, which will be our answer. And what our answer will be, like maximum sum is equals to maximum of maximum sum comma prefix sum minus min value comma prefix sum minus max value, right? Because as we have seen ever, like if we want to maximize the difference of two numbers, then the value which we are subtracting should be minimum. But as our prefix sum could be negative, so we want to maximize its value as well. So we will take the maximum of max sum, a prefix sum minus min value, and prefix sum minus max value. Okay, so in the starting, max value is 0, min value is 0, max sum is 0, prefix sum is 0. Okay, now prefix sum will become 1. Okay, so let's update our max sum. 1 minus max value, 1 minus min value, it will get updated by 1, and our max value will also get updated by 1, and min value will remain 0. Okay, now let's update our prefix sum. 1 minus 3 minus 2. Okay, now minus 2 minus 1, which will become minus 3, and we will take the absolute of it, so it will become 3. So let's update our max sum with 3. Now minus 2 0, absolute will be 2, so we will not update it as it is already 3. Okay, now let's update our max value. Maximum of 1 comma minus 2 1, minimum of 0 comma minus 2 minus 2. Okay, now let's update our prefix sum. Minus 2 plus 2 0, 0 minus 1, it absolute value will be 1. No, it's already 3. 0 minus minus 2, it will be 2. No, it's already 3. Okay, now let's update max value and min value. Max value is already 1, min value is already minus 2, so we will not update it. 0 plus 3 3. Okay, 3 minus 1, it will be 2. No, we don't need to update it. 3 minus minus 2, it will be 5. Yes, now we will update it. Okay, now let's update our max value. 1 comma 3 3 minus 2 comma 3 minus 2. Okay, let's update prefix sum. 3 plus minus 4, it will become minus 1. Minus 1 minus 3 minus 4, it will become 4. No, it's already 5. Minus 1 minus 2, minus 1 minus minus 2, minus 1 plus 2, it will be 1. So no, we will not update it as it is already 5. Okay, now let's update our max and min value. Max value 3 comma minus 1 maximum 3, minus 2 comma minus 1 minimum minus 2. So we have got our 5 as our maximum absolute sum. Okay, let's see. Yeah, here also output is 5. So in this way we can find the maximum absolute sum of our subarray by maintaining 3 variables: prefix sum, maximum value, and minimum value. Okay, let's try code it once. So we will maintain a n for storing the size of the num, and let's initialize three variables: prefix sum with 0, min value with 0, and max value with 0. Okay, let's start iterating in our array I is less than n, I plus plus, and prefix sum plus is equals to nums of I. And let's also initialize a variable max sum is equals to 0, and max sum will be maximum of max sum comma prefix sum minus min value comma prefix sum minus max value. And let's update our min value now, minimum of min value comma prefix sum max value maximum of max value comma prefix sum. Cool. Now let's return our answer, return max sum. Let's try run this. What I have done wrong here is, yeah, so I did forget to take the absolute values. Anyways, we need to take the absolute values. Yeah, let's try run this again. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexity. So as you can see, we are doing only one iteration. So its time complexity will be big O of n, and as we have not used any extra space, so its space complexity will be big O of 1. Okay, but one thing, if I tell you that I can also eliminate this thing from the solution, okay, let me tell you how. So what is our maximum sum? Like not maximum sum, subarray sum from a prefix array. Subarray sum is prefix sum of R minus prefix sum of L minus 1, right? Okay, so we need to do the subtraction between two things to maximize this value. So what if I will say that I will keep this value as maximum as possible, and I will keep this value as minimum as possible, but see, it is not equivalent to prefix sum of L minus 1 minus prefix sum of R. It is not equivalent to this. So how can I say that I will keep this value maximum and I will keep this value as minimum as possible? Because it might be the case this maximum value is the L minus 1 something and prefix sum of L minus 1, and this minimum value is the prefix sum of R. It can be the case. So how can I say this thing? Because in the question we have been given that we can take the absolute value. So if I will simply take absolute of this, then it will become PS of L minus 1 minus PS of R. So I can simply, this value will become simply equivalent to this, as I can take the absolute of this value. So that's why I can say that I will keep this value as maximum as possible and I will keep this value as minimum as possible. This will help me in giving the maximum absolute subarray sum. Okay, we can also see from this example as well. So the maximum prefix sum from this subarray is 3 and minimum prefix sum is -2. So 3 minus -2, 5, and which was our answer. Okay, let's try updating this thing in the code as well. So let's remove this and let's return max value minus min value, and let's also remove this maximum. Yeah, let's try run this again. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So although the time complexity and space complexity is all for this approach will also be big O of n and big O of 1, but the solution or the code was a little bit smaller. So yeah, that's all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.